Hello friends, welcome to our channel Fundamentals of Engineering. Today we are going to discuss the last point in the permutation, that is previous type gate questions and the expected questions we'll get for the gate exam. So in this session what we are going to discuss, whatever the previous gate questions based on the types of numerical we have seen in the permutation, that is number system and types of words. Based on that, whatever the previous gate questions were there, that questions we are going to solve, and we are going to see some expected questions that likely be come in the gate exam, that we are going to see in this today's session. We have already covered some permutations questions in part 1, 2, 3 and 4. The link is available in description box, you can check it. So today we are going to start the permutations, that we are going to discuss the previous gate questions. So before starting that, I request you to all to take the screenshot of these factorial values, because these factorial values are very much required whenever you are calculating the answer. So you have to remember all the factorial values whenever you are calculating the answer. No need to do all the calculations, like if you want to calculate 9 factorial, 9 into 8 into 7 into 6, 5, 4, 3, 2, 1. No need to do that. Directly remember this answer, that is 362880, that is the factorial value of 9 factorial. So hope you have taken the screenshot. Now we are going to discuss the important questions were there in the previous gate exams regarding permutation. We are going to see the combinations also, but later on. First we will discuss based upon this permutation. So first question that was there in GATE 2015 for 2 marks. Very easy question. If you know the concept and shortcut trick, you will get the answer. And that is the NAT type question. So we know in GATE there are 3 types of questions. One is MQC type, like multiple choice question, MCQ. Then NAT type, and in the last, in GATE 2021, this type of questions were added in GATE exam, that is MSQ type. So you will get any type of question in the GATE. So this question is for the NAT type. So how many 4-digit numbers can be formed with the 10 digits 0, 1, 2, 3 up to 9 if no number can start with 0 and repetitions are not allowed? So we have to form a 4-digit number. We have to form a 4-digit number, and they have given the condition that no number can start with a 0. So 0 will not be at first position. This will be first choice, second, third position and fourth position. And we have given the condition that the 0 will not be here at this first position. This can be at second, third and fourth, the 0 will become, but it cannot be at first position. So we have given the 10 digits. Among that, the 0 will not become at first position. So what are the possible choices we will get? What are the possible choices at first position? Among 10, 1 gone, so 9 choices, right? And they are given the condition also that repetition is not allowed. So whatever the number we have written here, we can't use that again. So we can't use 0 at the first position. So possible favorable choices we are getting 9. Then we can use 0 at second, third and fourth position. And we have already used one number. Suppose we have used 1. Then remaining are 9, because 0 we can use. So second position we can use 9. So if we are used 0, among this 10 we have used 2 numbers. So only remaining 8. We have used 3 number, so lastly at unit digit it will remain 7. So you have to do the multiplication, will get the answer. So 9 into 9 into 8 into 7 that answer you are getting 81 into how much? 8 into 7, how much? 56. Remember all the values. Do the calculation correctly. So based on that, 81 into 56, we are getting the final answer 4536. In GATE, the virtual calculator is allowed. So you can use the virtual calculator. We are going to see how to use the virtual calculator in next part, so that you will understand in the exam how you are going to use the virtual calculator. So that answer we are getting 4536, 4-digit number that can be formed by using the 10 digits 0 to 9 if no number start with a 0 and repetition is not allowed. Now second question. So how many integers are there between 100 and 1000, all of whose digits are even? So between 100 to 1000, between 100 to 1000. So between 100 to 1000 means we are getting 3-digit number. We are getting 3 digits number, because digits whose digits are even, all digits are even. So 100 we can't take because all digits are not even, and 1000 we can't take because we have to get in between 100 to 1000. So that is for the question in GATE 2019 for 2 marks. This is very easy. You will understand that it has to be formed a 3-digit number by using the digits should be even. So from 0 to 9, how many even digits are there? 0, 2, 4, 6 and 8. So how many? 5 choices. 5 choices are there, and they have not mentioned that whether to get repeated or not repeated. So we had to use the repeated question. Now among these 5 choices, 5 even digit number, we can't use 0, because if you use 0, then this will not be a 3-digit number. This will not be a 3-digit number, it will become a 2-digit number, and we have to form 100 to 1000. So we can't use 0 at the first place. So how many choices we can get at the first place? 4 at the first position, second and third. Now the digits can be repeated, so we can use 0 at second or third position. So all choices we can use at second and third. So 4 into 5 into 5. So how many? 100. So that is the option C. 100 we can get the integers from 100 to 1000 whose digits are even. Whose digits are even. Hope you understand. We are not using the formula, because if you are using the formula it will take more time to get the answer. So by using this shortcut trick, we are using and getting all the answers. 4 into 5 into 5. 3 choices, 3-digit number will get, 3 digits number will get in between 100 to 1000. How many? 100 number integers will get. 100 integers will get. Next, this is a very interesting question. The GATE, they are designed the questions in such a way that whatever the options they are given, there is a possibility that you will get every option. Whatever the points you are following, whatever the tricks you are following, based on that you will get the answer. But you have to follow the correct one and you have to get the correct answer. I will tell you what is the problem and interesting questions in the GATE the options are designed. So question is, an email password must contain 3 characters. A email password must contain 3 characters. So password should be of 3 characters, first, second and third, right? Then password has to contain one numeral from 0 to 9, one numeral from 0 to 9. So how many choices? 10. 10 choices that we are getting. Then second, one uppercase and one lowercase character from the English alphabet. One uppercase and one lowercase from the English alphabet. So English alphabet means we have to use alphabets. How many alphabets are there? 26. So 26 choices we are getting for the uppercase and for the lowercase. Right. So 3 characters we have to form, which having the email password. So at password we need to form. So we can use 0 at the first position. 0 at the first position we can use. So if we write numerals at the first position, how many choices are there? 10 choices. So we can use here 10. And one uppercase letter if we write at the second character, then we are getting 26, and lowercase at the third we are getting 26. So 26 into 26, 26 square. To get the square and square root, cube and cube root, the video we are already prepared. You can see the different playlist of that, and based on that how many answers we are getting? 26 square, that is nothing but 6760 into 676 into 10. So based on that 6760, that is the answer. Now you will get that, sir, first option is correct, but that is not the correct answer. What they are given, there must be a 3 characters. 3 characters. So if I am writing this password, there is a possibility that I can use numeral at the second or third. I can use uppercase at the first or third. I can use the lowercase character at first and second. So these 3 characters I can use in a 3 different ways. Means these 3 characters I can use in a 3 different ways, means 3 factorial ways. So total distinct passwords which are possible, these are nothing but 6760 into 3 factorial, So 3 factorial value is 6. So we are getting 6760 into 6. So do the multiplication. 0, 6 into 6, 36, 6, 7 are 42, and 3, 5 you are getting 4, 6, 6 are 36 plus 4, that is 40. So 40,560. So you can see both options you are getting, but if you are written this, that will be the wrong answer, and with the easy question you might be losing the 2 marks. The important 2 marks you can lose. So remember and understand the problem in aptitude. That is the most important. You have to understand the problem, what they are given and what they want to calculate. So these are the possible choices, and 3 characters we can write with the 3 factorial ways. So total distinct password which are possible, that is nothing but 40,560. 40,560 that can be possible. So see how the gate they are designing the options. There is a possibility that you might be selected option A, but that will be the wrong answer. So understand the problem, and based on that problem find out how much things are given, and you will get the correct answer. So correct answer is 40,560. Hope you are enjoying all the questions. If yes, put in the chat box as yes. Hope you are enjoying. Write in the chat box as yes. later on you can comment in the comment box if you are getting all the points clear. The permutation problems are very easy, but you have to do the practice and you have to solve the questions in a such a way that they are given the whatever the possible choices. So based on that you have to solve the permutation problem. Now next question, this is also an easy one, and here you will get the two options, but the correct options you have to choose. So what is the question? If 4-digit integer numbers from 1001 to 9999, the digit group 37 in the same sequence. So 37 will become as a 37, not 73. 37 will be at 37 in the same sequence. Appears how many times? How many times? It is for GATE 2020 for 2 marks. The aptitude questions are very easy and the syllabus is same for the all branches. So don't think that these questions will not become for your paper. The aptitude syllabus is for all branches which are same. So now the digit 37 in the same sequence appears how many times in between 1001 to 9999. So we have to get a 4-digit number, because you can see in between this. So we have to form a 4-digit number. So how many appears time? So there are possible choices. So at the first position the 37 might be get, right? So this is the first choice. Second choice, in between 37, that is the second choice. And third choice, that they will appear at the last. Now we have to form the favorable choices. Now see how many times you will get. Now 4-digit integer numbers. So integer numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So how many choices? 10 choices we can get. So among these 10 integer numbers we can write here. Now see, first one, 37 will be at first. So at the second and fourth. So all 10 numbers, there is a possibility that will come. No, all 0 will become here also. So all 10 possible choices. Here at the first, all 10 choices. So this will be a first choice, this will be a first choice. So these are the one type. So 10 into 10. So how many? 100 possible choices will get when 37 at the start. So in between. Now at this position. So at this position how many? We can't write 0, because if you are at written 0 like this 0371, then it will be a 3-digit number and we have to form a 4-digit number. So we can't write 0 at the first position. So this here how many choices? 9, and at the last we can use 0, so 10. So 9, this 1, this will be 1. So how many? 9 into 1 into 1 into 10. So how many? 90. Right. Then here also at the first position 0 will not be there. So we can get 9 possible choices. Second position will get 10 possible choices. This will be 1, this will be 1. So 9 into 10, 90. So how many total we are getting? 100 plus 90 plus 90. 100 plus 90 plus 90. So we are getting 280. But this is not the final answer. We will get that, sir, C option is there. And why you are not saying that this is not the final answer? See here, if we are writing 37 at the first position, and we can use 37 at like this. So this will be possible. And 37 at the second position, this will be there, right? So you are getting this repeated number. repeated number. So we can't use this 2, we have to use only 1. So from this you have to deduct 1. So from this you have to deduct 1. So 280 minus 1, you are getting 279. That will be the final answer, 279, option D. Why? 37, 37 and 37, 37. This will be the repeated number. We can't use two numbers. We have to use only one. So these cases you have to use only one, or from these cases either one. So we have to deduct 1. So from this 280, these are the total possible choices. Among that, repeated number, one repeated number, we have to reduce that. So we are getting 279. We are getting 279 as the final answer. So here also you can see option C is there based on this, but this is not the final answer. So understand the concept, and based on that you have to get the correct answer. 279 is the correct answer. If you are getting any doubts, you can put into the chat box or you can comment. If you are enjoying the session, like the session. If you are not subscribed this channel, you can subscribe it. You can see the different playlist based on the GATE exam and other aptitude types. Maths also you can get the different links. Now the next question, interesting one. Based on the words type 4 which we have solved, that never together. Based on that, this is for the numbers which are never together. So what is the question? So how many numbers of 3 digit can be formed such that digit 1 never to the immediate right of 2? Digit 1 never to the immediate right of 2. It is for the GATE 2017 for 2 marks. So we know when there is a never together, immediate right of 2, never, immediate right of 2. So whenever we are having the never together condition, we have to use the formula never together is equal to total choices minus always together, you will get the never together answer. You will get the never together. So total choices minus always together. Now first condition we will see, total choices. So total choices by neglecting the given condition. So 3 digit number we have to form. First, second and 3 digits. So by using the digits 1 to 10, 1 to 9. So how many? 10 possible choices. 1 to 9 we have to use. That will getting 10 possible choices. So 3 digit, at the first position we can't use the 0. So how many choices that can be possible at the first? 9. Now we can use 0 at the second or third. So how many choices? 10 and 10. So we are getting how many? 9 into 10, that is 900. In a second way also we can get that highest 3 digit number is 999. From that, the first 3 digit number, last 2 digit number is 99. So if you deduct that, you are getting 900. So by using this also, this is by the shortcut trick we are solving, and this is by the concept we know. Now these are the total choices we got. How much total choices? 900. Right. Now always together. Second is always together. Means one is immediate right of 2. One is immediate right of 2. So what are the possible choices we are getting? One is immediate right of 2. The reverse we are solving. So 2, 1 and this is the possible case. 1 is immediate right of 2, that is the first choice. Second choice, what we are getting? This one. Third, this will not get, because if you are writing 2 at the unit place, because at the right of 2 it will not get, so this will not be condition. Only these 2 possible choices that can be we are getting when 1 is immediate right of 2, always together. So how many choices are there at the unit place? From these 10 choices we can use 0, right? So this is one position, this one position. So 10 into 1 into 1, we are getting 10. Now at the second, how many choices are there? We can't use 0. If we are using 0, we will not get the 3-digit number. So 9, this will be one position, this will be one position. 9 into 1, that is 9. So addition, 10 plus 9, 19. 10 plus 9, 19. So we got total choices as 900 and always together as 90. Always together as 19. So 900 minus 19, that will be the final answer. 900 minus 19. What is the answer? 900 minus 19. Put into the chat box. Simple one. Which option is correct? We have solved in the reverse way, that we have solved in the word problem never together. When the vowels are never together, consonants are never together, or other letters are never together. There we have seen this formula, that whenever we are getting the never together, from the total choices we have to subtract the always together. So by using this formula we are getting the answer. So we are getting the total choices minus always together. So you can put the answer in the chat box. I will leave it to you which option is correct, which is simple one. Based on that we are getting. Now this question is very interesting, and that way came in the GATE 2003 for 2 marks. So there is a possible choices that this type of example will become in the next GATE exams. There is a possibility. So what is the question? That young couples are invited at a party with the condition that every husband must be accompanied by his wife. So first condition is given that every husband should be accompanied by his wife. Yes, Pratik, correct answer. Thank you. Option C. Second condition, that however a wife need not be accompanied by her husband. So wife can be go with someone else. That is the condition given by the question itself, not by my. So how much such different gatherings can be possible? So young couples are invited at a party. So first condition, that every husband must be accompanied by his wife. So if husband is going, wife should go with him. Then second condition, a wife need not be accompanied by her husband. So wife is going, then there is not a condition that the husband is going. So possible choices that we are getting, so based on these choices we have to find the answer. So first we will see that both husband and wife is going. So both will go. So what are the choices we are getting? Husband and wife. I given the notation for the husband as H and wife for the W. Both will go. This is the condition that we are getting. If husband is going, wife should be accompanied. Second possible choice is that only wife goes. Only wife goes. Means you can see that wife need not be accompanied by her husband. So wife can go, but it is not condition that it will not be her husband. So H husband I will mark a cross and wife. That is the second. Now third, if they are invited need not be they are going, need not be a possible case that they will go, both husband and wife they are going. So third condition that both did not, third condition both did not go, they got they keep in mind that will not go to the party, so both will not did not go, so that is the possible case. So how many choices we are getting? 3 choices, 3 choices we are getting, right? So the couples are invited at a party, n couples. We are not focused n couples till now, but now we have to focus in n couples to get the answer. N couples are invited. So couples 1, 2, 3 up to n couples they are invited. So among that, what are the possible choices that we are, that all 3 goes? So 3 choices there will be possible for the first 3 choices up to n 3 choices. So whatever the answer we are getting, that we are multiplying. So 3 into 3 into 3 into up to n, right? So based on that, so answer we are getting 3 raised to n, 3 raised to n, because 3 possible choices, both will go, husband and wife, only wife goes and both did not go, they are invited to the party, they invited to the party. So these are the 3 possibles we are getting, and based on that, how many different gatherings are possible? 3 raised to n, 3 raised to n, that is the answer we are getting, that is the answer. Now we have seen the expected previous gate questions. Now we will see the expected questions that we are getting. So first question that is expected, I am getting that there is a possibility that this type of questions will be there in the your gate exams. So how many different 4-digit passwords can be formed if the digit 5 always occurs? Assume repetition is not allowed, digit 5 is always occurs, and we have to form a 4-digit password, 4-digit password we have to form, password we have to form 4-digit, and digit 5 always occur. So digit 5, suppose we are having 4, 3 and 4 position, 4-digit password. So 5 if it is occurred at this first position, so first choice will be there. Now in the second choice, repetition is not allowed, repetition is not allowed. So how many digits we are having? 0 to 9 we can use, so 10 possible choices, 10 possible choices we are having. Among that 5 we are already used at the first position, assume that first position we have used, so remaining are 1 gone from the 10, remaining is 9. Now 2 gone out of 10, remaining 8, and 3 gone out of 8, remaining is 7, remaining is 7. Now there is a possibility that it will come at the first position, or we can write the digit password while taking the 5 at the second position or third position and fourth position, second position, fourth position, third position and fourth position. Also we can use 5 at the last, second, third, right? So how many times we can use that 5 digits? Out of 4, all 4 choices will be there. So possible arrangements we are getting that 5 always occur, so it can be occur at 4 times, so 9 into 8 into 7, 9 into 8 into 7. So possible arrangements 4. Why 4? Because 5 can be appear at the first position, 5 can be appear at the second position, 5 can be appear at the third position, 5 can be appear at the fourth position. These are the possible choices, right? So 1, 2, 3, 4 possible choices we can get here, and remaining are 9 into 8 into 7, because out of 10 we have used 1. So whatever the answer you are getting, you have to put into the chat box. 4 into 9 into 8 into 7. You have to put into the chat box. Answer you have to put into the chat box. Hope you are enjoying the session and you are getting all the points which we are discussing. Comment the answer in the chat box. 4 into 9 into 8 into 7. We'll move towards the next question. So how many different 4-digit passwords can be formed if the digit never occurs? So last question we have seen the 5 digits always occur. Here the digit 9 is never occur. Digit 9 never occur. So I am having the allergy with a 9 number. So I can't use the 9 number. So whatever the remaining numbers are there, we can use. So how many remaining numbers? 0 to 9. So how many possible choices? 10 choices are there. But among that, I am not using 9. 9 never occur. I am not using 9. So how many choices? The choices we are getting 9 choices, because 1 gone from the 10, 9 is gone. So how many choices? 9 choices. So how many 4-digit password can be formed? First, second, third and fourth. So 9 choices which are there, all the 9 choices will be fixed at the first position. We can use 0 because we are not here to form a number, we are here to form a password. So password can start with a 0. So 9 possible choices will be there and repetition is not allowed. So 9, if we have used 1 digit we have used, we can't use again. So among that 9, 1 is gone. So we can use 8 at the second, third we can use 7 and fourth we can use 6. So if you are having the virtual calculator or any calculator with you, based on that find out the answer and put into the chat box. So 9 into 8 into 7 into 6. 9 into 7 into 9 into 8 into 7 into 6. So based on that, what is the answer? You have to put into the chat box or in the comment box. You have to multiply. We are multiplying all the possible choices. So these are the different passwords can be formed. So use the virtual calculator. 9 into 8 into 7 into 6. (42) into 8 into 9. So I am doing that calculation for you. So final answer we are getting 3024. You can cross check. So 3024 distinct passwords can be formed when 9 never occurs. You can cross check answers. Now next question is based on the word type problem. So how many different words can be formed from the letters of the word evening? So we are having the word evening. So what we have to do? We have to form different words, possible arrangements that can be possible. We have to form. So first count number of letters which are there in the word evening. 1, 2, 3, 4, 5, 6, 7. 7 letters are there. 7 letters are there. So now we will see the arrangements. So possible arrangements that can be get 7 letters. So we have to count the number of letters and we have to take a factorial. We have to take the factorial. But here there are repeated letters. So number of repeated letters, factorial we have to divide with this number of letters to get the final answer. So how many letters? 7 letters are there. We are getting 7 factorial. Number of repeated letters, because E is repeated twice. So you can see E and E second. Also N is repeated. N Yeah, 2 times. E is repeated 2 times and n is repeated 2 times. So we can write at the denominator 2 factorial into 2 factorial. See here, don't use like this 7 factorial upon 2 into 2 factorial. If you are doing that, you will get the wrong answer, because here we are getting 7 factorial upon 4 factorial. But you are getting the wrong answer. Don't do this. Whatever the number of repeated letters, first repeated letter you have to take the factorial. If there are another repeated letters, then you have to take multiplication with another repeated letter factorial. So 7 factorial upon 2 factorial into 2 factorial. So whatever the factorial value I have given in the start of the lecture, if you have taken the screenshot, based on 7 factorial value is 5040, divide with 2 factorial is 2, 2 factorial is 2. So 5040 divide with the 4, 5040 divide with the 4, that you have to get the final answer, So 4 divided with 5040 divided with 4. So 4 ones are 4, 1 remaining 2, 5, 4 twos are 8, 2 remaining, 4 6 as 24 and 0. 1260. These are the different words can be formed by using the letters evening. 1260. 1260. Now the next. So how many different 3-digit numbers can be formed where the unit digit is always 0 and repetition is not allowed? So here what is the condition? We have to form a 3-digit number and unit digit is always 0. So 0 will be appear here at the unit digit. So these choices will be fixed. 0 will be appear at here only, right? Now how many digits can be formed? So digits are 0 to 9. So how many? 10 choices. But we have used 0 used. So how many choices are remaining? 9 choices are remaining. 9 choices are remaining because the unit digit 0 must be fixed. So 9 choices we can use at the first position, first, second and third, the unit place. So at the 10th place, how many possible? 9. And at the 100th place, how many possible? 8. See here, unit place is fixed. 0. So this is the possible choice, one possible choice we are getting. At the 10th place, we can use all 9. Right? Now repetition is not allowed. So 0, it is already fixed. We have used 9 among the 1 to 9 we have used. So if number 1, if we are used at the 10th place, we can't use again at the 100th place. So from the 9, it remaining only 8. So 8 into 9 into 1, not a 0. 0 is the fixed position. So one possible choice there. So 8 into 9 into 1, that is 72. That is the final answer. 72. That is the final answer we are getting. 72. That is the final answer when the unit digit is fixed. So friends, we have seen all the previous gate questions regarding the permutations. We are going to discuss the combination concept and the questions also in the next part. Stay tuned for this. And we have seen the expected gate questions regarding the permutation. Hope you have enjoyed the session. If you have enjoyed, you can comment in the chat box or in the comment box. Don't forget to like the session and don't forget to subscribe. You can share this content with your friends. So here we'll stop. Thank you for listening. Have a good day. Thank you very much.